In this video, we're going to use a TI calculator for hypothesis tests for a population mean. Here's our hypothesis, and mu is equal to 20, h1 with less than 20. So a simple random sample size of 16 is obtained from the population that is known to be normally distributed. So remember, we either need that sample size to be greater than or equal to 30 or know it to be normally distributed before we can move on. All right, and these are the numbers. It's quite quick in the TI. So you have x bar and then the standard deviation of the sample. So here's the calculator. You click Stat over to Tests down to the t-test. Now this is going to find the t statistic value and the p-value. So these directions work both for finding t statistic and p-value. Now the input are going to be stats because we already have them. If you have raw data, which I'll show in a moment, you use that one. Go down here, enter the data. Mu naught is 20, so I'm going to put 20 in there. X bar is 18.3. Standard deviation, 4.3. N is 16. And then we want to calculate a less than, right? So we leave that on less than and we go down to calculate. You'll notice that the t statistic is negative 1.58. It does have a p-value of 0.0673, and so I don't know if they have an exact here, but they have an approximation of a p-value there for us. So this allows for just a t statistic and a p-value, and this was approximate a p-value. If you need to draw a t distribution here, you can see it's a left-handed test, so it would be on this side. And then we'd basically make the conclusions. And there are two ways to make that conclusion at the 0.05 level significance. With the t statistic, negative 1.58, we can go to the t table here, and we can look at the 0.05 level significance, and then use the degrees of freedom. There is 16, and we go down till we get to 16 degrees of freedom, and we notice that it's 1.76. Now, since this is a left-hand tail test, left hand, we make this negative 1.746. And if our t statistic, negative 1.58, is to the left of negative 1.746, then we will reject the null hypothesis. But since it is not less than this critical value, it's to the right of it on the chart, we do not reject the null hypothesis. Now if we look at the p-value and do that calculation, 0.05 level of significance, our p-value is 0.06. So again here, it goes, if the p-value is less than the level of significance, we reject the null hypothesis. But since the p-value is not, it says the researcher will not reject the null hypothesis since p-value is not less than alpha. So there are two ways to use the information to reject or not reject the null hypothesis. Now we're going to look at a question with some data that we have to enter. So the mean waiting time at a drive-through fast food restaurant for the time an order is placed to the time the order is received is 86.1 seconds. A manager devises a new drive-through system that she believes will decrease the wait time. As a test, she initiates the new system at a restaurant and measures the wait time for 10 randomly selected orders. The wait times are provided in the table. All right, so since there's only 10 orders here, we need to confirm two things. We need to confirm that it's normally distributed, which by doing the probability plot, we can see that here it follows the line. It is not outside of these bounds, so it's normally distributed. And there are no outliers with the box plot. The conditions are satisfied to move on. Now, is the new system effective? Well, the hypothesis is that mu is equal to 86.1, and we want to be less than that. It says the wait time will decrease. Okay, so we need to find that t statistic. So we put this information into the calculator. And I've kind of done that already to save some time, but how you do it is you click Stat and then Edit, and then you enter the values in. So I've got all 10 values in here. Then what we do is we go back to Stat, over to Tests, and then down to T-Test and hit Enter. Now instead of having the stat selected, we have the data. So we select data and hit Enter. Now we enter our information in from here. The mu naught is the 86.1. The list is L1. You want to make sure that's highlighted. Go down. Frequency, leave that at 1. And then we have a less than again. So we're going to go less than, have that highlighted, and then click Calculate. So this will give us our t-value of negative 1.549, or negative, yep, that's what it is down here. So that's our t-value. And then it's going to ask for us to find the p-value. Well, this does that for us. Also, so 0.0778, or round up to the 0.0779, excuse me. Okay. And then we need to use the 0.1 level of significance and what can be concluded by the hypothesis test. So since they did p-value, they're going to look at the p-value and determine that. So 0.1. Well, this is less than 0.1, right? So our p-value is actually less than the level of significance. So we're able to reject the null hypothesis and say the p-value is less than the level of significance, so there's sufficient evidence to conclude the new system is effective. So they don't say reject, but that's what we do. We can reject the null hypothesis and say there's enough evidence that yes, the new system is being effective. And just a quick check, we can actually see that on the T table as well. The 0.1, and then how many degrees of freedom? 9. 1.8383. It's a negative because it's a left-hand tail test. Our negative 1.549 is to the left of that, which would also say that we reject it. It's in that critical space. So that's how you do the hypothesis testing on a population mean with a TI calculator.